Hello, students. This is our Smart Kids Learning Center tutoring class. Our contact number is 647-778-8725 for online class. We majorly tutoring high school subjects for advanced function, calculus, English, as well as teach students do all school subjects homework. And for new students will receive the first free online class. Please feel free to contact us. And now we are going to start class. The textbook I'm going to teach today is a McClaw-Hill Ryerson, Advanced Function, grade 12. So I hope you have the same textbook, but if not, it doesn't matter. And since all the school textbook grade 12, they are the same concept at a grade 12. You can learn the concept and the skill, apply for any textbook. And I'm going to teach you unit 1.3 for identify even function, odd function, and how are you going to learn these formulas and concepts. Let's start. On page 37 in the textbook for 1.3, example 3, identify symmetry. Now I'm going to read it and also explain to you and with writing too. Now it's giving you without giving you a graph, and then you are going to determine each of the function, what kind of symmetry, and also whether they are even function or odd function. Now, let's start the first one. So the first one is for f and x is equal to x exponent 4 minus 5x exponent 2f4. So this is an even function. I'm going to show it to you. Now I'm going to explain to you what is an even function. It means when you substitution negative x into the function, you get a positive function that's called even function. Now there's a two way, very easy to identify. So first, you're going to identify for all the terms. If here all the terms, the degree are even, yes, this is an even function. It's going to be symmetry about the y-axis. Now, first one. And the second one, what is an odd function? Odd function, when you substitution f at negative x, you get the negative y. That's odd function. Now, you can jot down a simple note. All the terms are odd degree. And then that's going to be an odd function, symmetry about the origin. So I'm going to give you in an example 3 for the B, example B. Now you have an f and an x. It's equal negative 3x exponent 5 and 9x exponent 3 and 2x exponent 1. You see all these exponent odd degree. So you don't even need to substitution into the this taxon formula to see if it's an odd. So 100% is an odd degree. It will be symmetry about the origin. So if you plot it, it will be like that. Symmetry here. So you can make as many curved lines as you can to make it symmetry, but the basic concept is like that. So it's an odd degree. Now, if you want to substitution into the formula, you can do that. So f at the negative x, so it's equal So -3 with substitution negative x exponent 5. So and then at 9x, x is going to be a negative x exponent 3. And then add to negative x exponent 1. So and when you simplify, so what are you going to get? You're going to get a 3x exponent 5. The next term minus 9x exponent 3. The next term minus 2x. Now, it means when you substitution negative x, you're going to get a positive function, positive y. So, and then if this is so it's equal for a negative, f a negative. So the original function, so these are the positive. So we're going to factor it. So if you factor a sign, you're going to have a negative 3x exponent 5 at 9x exponent 3 at 2x. If back to the original equation, look at inside the bracket, and you're going to get a negative f and x, you're going to get negative f and x. So therefore, this is an odd function. If you want to substitution into equation, you can evaluate like that. But the most simple way, you only need to do evaluate the degree. All the terms even degree, even function, symmetry at the y-axis. All the terms are odd degree, they are odd function, symmetry at the origin. Now I'm going to give you more examples, like the one neither, not odd, and not even function. So let's look at the example C. So if you have an f and x, it's equal 2x times x at 1 and times x minus 2. So it's hard to tell when they are in a term like that. We are going to do distribution and combine it. So we have a 2x times xx, x squared, negative and 1 minus x and minus 2. Now we are going to make the one for, that's only for the x term. Now we continue. So negative 2 times x, we're going to have a negative. Now we're going to combine the last term. We're going to have a 2x exponent 3 minus 2x exponent 2, and then minus 4x. So is this an even function or odd function? No, not belong any of this type. They are neither. So see the degree, you only need to identify one for odd, one for even, and one for 1. So if they're not consistent, neither for even or odd, so and these type, so they are not symmetry at the y-axis and at the origin is exponent 3. So you're going to write symmetry not at the origin. So is symmetry not in the origin, and also they are not odd or even. Yeah, we just write it. So it's not even or odd function. Now I'm going to do one more, show it to you for a D. So D is x exponent 6 minus 4 x exponent 3 and 6x exponent 2 minus 4. So do you need to substitution for the formula like f at negative x is equal f and x to prove this is neither even or odd. So this is even. The equation to text. This is odd. So are we going to substitution into the testing formula to find? That's too much work. So you can use a simple way to identify. Now, even degree, odd degree, even degree. They are not consistent for neither type. If odd, consistent, each exponent are odd number. So will be an odd function. So if it's even, each term, even degree will be even function. So therefore, for this one, is symmetry not at the y-axis. Yeah, I write short form. Not about the y-axis. So it's not even. Or odd. So that's how you explain it. Use a very simple way. Check the degree. If the degree consistent, even number, even function. Consistent, odd number, odd function. If they are different degree in a polynomial function, so this function will be not odd or not even function, not belong to any of this type. So they are not symmetry at the origin and not symmetry at the y-axis. That's how we explain even function and odd function and work it out easily without a lot of work substitution into the formula to do tests. So you get the concept and the skill. Apply for your exercise. If you have questions, feel free to text me. I will write you solution. The question is from the Ryerson Advanced Function Grade 12 for the Unit 1.3 Example 3. So, and continue, do your homework, and please subscribe. I'm going to continue explain to you the concepts and exercise in the next video. Thank you. Bye.